Okay, there are some integrals where you have to change the order of integration in order to calculate. And here's an example. If you have 0 to 2, y squared to 4, y cubed cosine x cubed dx dy. This is an integral where you can't integrate as given. You have to change the order of integration in order to calculate. See, cosine x cubed cannot be integrated by any methods that you know, whether you use u substitution, enrichment cards, you name it, it doesn't work. So trying to calculate in this format is impossible. You have to go from this to dy dx. So here's the question. Let's try to solve it. Step 1 is to first draw the domain, and using that you have to figure out how to change the order, and after you change the order, then you can compute. That's the end. Okay. All right, so first of all, you have dx here. That means this should be thought as x equal to y squared and x equal to 4. Okay, what's x equal to 4? That's a vertical line, right? So passing through 4. That's what x equal to 4 is. Now, what is x equal to y squared? Well, x equal to y squared, if you want, you can solve this for y and get y equals to what? Plus or minus square root of x. When you get rid of square, you have to use the plus or minus. Y equal to square root of x. How does the graph look like? This is y equal to square root of x, right? But then there's another graph, y equal to negative square root of x.
Reflection.
It's a reflection over the x-axis, so that's y equal to negative square root of x. And therefore, the original graph, this thing, actually gives you both. Okay. Now, putting them together, you end up with the following graph. You have a graph that's like this, and here's 4. That's what you get. Okay? And then because you begin here and you end there, and because you're using dx, you're trying to paint it rightwards, so you're trying to paint it rightwards. And then you look at the y value is from 0 to 2, so what do? Here's 0, and I think this is the point where you get 2. So you end up with just this part. So you're painting this region because you start from this curve going right, and you end at that curve, with the minimum value of y being 0 and maximum value of y being 0. That's the domain that you get. Okay? Yes?
When y equals 4, shouldn't x equal 2? Not the other way around. Oh, never mind. No, you're right.
No, okay, so right. If x is 4, if x is 4, you get y squared equal to 4, you get y equals to plus or minus 2, so y is 2 and y is negative 2 when they meet. All right, so that's the domain. Now we have to go to dy dx. So let's try to think about expressing this domain using dy dx. So if you try to use dy dx, you're trying to paint upwards, so you're trying to go like that. So where do you begin?
0.
Here. What's that? What's the equation? Y equal to 0. What's the equation for this?
Square root of x.
This one, right? Y equals to square root of x. Therefore, you put 0 here and square root of x. Now, what's the minimum value of x? 0. Maximum value of x?
2.
No. 4. It's 4. Maximum value is 4. So it's 0 to 4, and then you're integrating, and whatever. Okay. All right. So let's actually write down the resulting integral, and we can calculate it. Okay. So what are we getting? We have 0 to 4, 0 to square root of x, y cubed, cosine x cubed, dy, dx, And that one is really easy to integrate. Everyone can integrate y cubed. Everyone knows 1/4 of y to the 4th. And then 0 to square root of x. And because this is y equal to square root of x, these are going into y only. It doesn't go into x. Only to y, okay? So you still have to integrate with respect to x. So 0/4 stays here, and you still have to integrate by x. And then square root of x should go in here. Now what's square root of x to the 4th? That's x, yeah, square root of x squared and then squared, right? 4 is 2 times 2, so you can think of it like this, so it's x squared. So when this goes in here, that's x squared. When 0 goes into y, that's 0. Therefore, you end up with, from 0 to 4, 1/4 x squared cosine x cubed dx. And now we have to integrate that. Okay. Now, whereas trying to integrate cosine x cubed itself is impossible with any methods, now this is possible. You can integrate this. How? U subs. Take u as x cubed, right? Because if you differentiate x cubed, you get 3x squared, and x squared is right there. So that's going to be canceled after u substitution. So let's do that. Let's do that u substitution. U substitution, I take u as x cubed, so that du is 3x squared dx, so that dx is 1/3x squared du. Using that, now, also, when x is 0, u is 0. When x is 4, u is, what's 4 to the cubed? 4 times 4 times 4 is 64. And you have 1/4 x squared cosine u, then 1/3x squared du. And you can see that x squared and x squared are common, so they cancel. 1/3 times 1/4 is 1/12, so you can take the 1/12 outside the integral. Now you only have to integrate cosine of u du. What's cosine u du? Sine of u. Right? Integral of cosine u is sine u, and you plug in 64 and 0 into u. So when you plug in 64, you get sine of 64. I don't have any idea what that value is, but that's what it is. And then when you plug in 0, what's sine of 0? 0. Sine of 0 is 0, right? So you end up with 1/12 sine of 64 minus 0. And that's not needed. So that's the answer.